Okay, so thank you very much for coming to this session about the hybrid cloud. I call it cloud. You'll see why. The slides are in bit.ly/hybrid cloud Java. You can see it here, so you can follow. Also, there are some links that maybe I will need to update it. But basically, I just show with you the slides because then there are some links where you can access and we can play together. So let's start. Uh, my name is Alex Soto. I work in Red Hat. My Twitter is Alex Soto V. You can follow me there. If you want to stay updated with Kubernetes news, Istio, Knative, Tecton, Argo CD, all this Kubernetes stuff out there. So I usually tweet about it. Also about Java, of course. And if you got any question that now, for example, we do not have time to answer, then you can also make it on Twitter, or if you feel more shy, also my email, soto@redhat.com. You can also send me there an email with the question. And finally, I'm the co-author of Testing Java Microservices, Quarkus Cookbook, and Securing Kubernetes Secrets. So let's just start about a definition. What is a hybrid cloud? Hybrid cloud is a cloud computing environment that connects a mix of public, private clouds, and also on-prem infrastructures. And now you can see basically this is an example where maybe we want to connect an Azure cloud with a Google cloud, with Amazon cloud, and even on-prem cloud. Okay, so it's a way to connect to all these clouds from our application. And well, of course, this is not something that all of us needs to do. It depends a lot on your business case, about also the size of your company. But it has some advantages that we will see in a few moments. The principles of open hybrid cloud is that the first thing that we need to take care about is that it's the consistency of user experience, which means that it doesn't matter if I am in Amazon, I am in Azure, or I am in GCP. The experience from the point of view of user should be always the same. And notice that this is something that we can get it if we are using Kubernetes, because at the end with Kubernetes we do kubectl apply, and that's all. It doesn't matter if your Kubernetes cluster is in Amazon, if it's in GCP or AVM cloud. Doesn't matter. You do kubectl apply, and always the experience is the same in all the clouds. Also, we need to have the flexibility of deployment across hybrid or multi-cloud. So we need to be able to deploy in one specific cloud or in all of the clouds. It's really interesting that we need to be open all the time. It means that we can use any of our preferred tools in any of the clouds. For example, if you like to deploy your application using Argo CD, right, then it should be open and you can choose the deploy an Argo CD in any of the clouds. If you, for example, just prefer to do something like Jenkins plus Helm, then also it should be valid. Also, you need to be able to access the latest innovations. This is one of the great things about hybrid clouds, that you can access to the pieces of software that are implemented in each of the clouds if you require it. And of course, hybrid clouds helps you on reducing the risk of something goes down, the reliability of your site, because if you have your application deployed in several clouds, if one cloud goes down, it doesn't matter, you've got another one, another backup cloud, but you can send all the traffic there. And also it helps you to build some trust on your application, because you know that you can run it in any cloud. There's no vendor locking to one specific cloud. You can move it from cloud to cloud without any problem. So you build a trust on your application. And of course, as I said, if you're using Kubernetes, then you get a lot of these points covered. But what are the advantages of hybrid cloud? Why I should go to a hybrid cloud? Well, the first advantage, and it's pretty obvious, is that there is a disaster recovery. What's happening if one of my clusters goes down? Maybe because my application is on Amazon and then S3 goes down. Remember that this happened some years ago. Okay, then you can always have a backup plan to another cloud and reroute the traffic there. Also, is the lower latency. What's happened if I'm a worldwide company and I don't want to have just one cloud in, for example, US. I want to have one in US, another one in Europe, another one in Asia, because you can get it lower latency. Because at the end, the packets travel across the network, and the near are where the packets are originated, the fastest you get it a response. And finally, this is really one important is data sovereignty. There are countries that do not let private data cross the borders. For example, in case of Germany, you might say that the government of Germany says that any important data of a user should be all the time in a German data center. And that's fine because, you know, GCP, so Google, Amazon, Azure, they have data centers in Frankfurt, so that's not a problem. But what's happened if you go to a country where it's only Amazon and your application is always deployed on Azure? Then you cannot sell your solution to that country because you are not into the hybrid cloud. Your application has not been designed to be hybrid cloud. So being a hybrid cloud is also really important. And you'll see that when we are into the Kubernetes and we want to start using hybrid cloud, what we really need is a project that is called Scupper. You need to think as a Scupper as something like this. It's a project that works at layer 7 of the HTTP, not layer 4. And this makes things really easy, okay? Because you have your pods, you have your services in each of your clouds, in Azure, in Google Cloud, in Amazon, or on-prem, but also you've got here the special Scupper piece. But as I said, works at level 7 using HTTPS and makes, you know, that you can administrate all your clouds in a really easy way. Then, when you're sending a request, this request is not sent directly to the to a cloud, but to the Scupper part. Okay, then this Scupper part, just find which is the best cloud to get this to get this request and send it there. And you do not need to worry about security because all the traffic of a Scupper is managed using MTLS and it's encrypted at, you know, at HTTPS level. So it's really, really easy to control and really, really easy to secure. So you need to think about like a Scupper, like a proxy that receives a request and send it to the best cloud. And probably you might be wondering, what is the best cloud? What is, you know? And then here it depends, right? Sometimes it's depending on the distance, okay, between clouds. Sometimes if it's for a backup cloud, then it depends if the primary cloud is failing or not. In this case, we're going to see this demo, okay, which is, oops, sorry, that you can see it in this GitHub repo. And basically, it's demo that works or shows you the hybrid cloud, but as a backup. So you've got a primary cloud and a secondary cloud or a backup cloud. And when the first cloud fails, automatically all the requests are sent to the backup cloud. I've got here the application. It's this one, okay. And this is a really simple application. It has a front end and it has a back end. Here I can send a message. For example, I can send Alex. And if I send a request, you see that it says me, it's this one. It returns Aloha Alex in uppercase because I checked this. And here, this shows me which cloud processed the request. Okay, I didn't explain it, sorry. But in this case, I've got my application deployed in 2 clouds, one in GCP and another one in Amazon. And this is the GCP. I can do kubectl get pods. You see here that I've got here the front end. Wait, I'm in the wrong. Give ns default. Give Carol pods now. Oops. Okay, you see that I've got here the backend and here I have the front end. We can visualize it here. This is the here. This is the let me change it to default. This is, I'm going to, sorry, because I've got the default namespaces. Okay, here I'm in the default namespace. You see that there is a front end, there is a back end with one pod each one. And here I'm in Amazon. See that this is a cluster, Kubernetes cluster running on Amazon. And again, I've got here the backend. Okay, so again, you can go here, you can put hi. I do send a request and see that this is processed by GCP. So it means that it's processed by this backend. Now, let's simulate a failure. Let's simulate that this backend is down. Maybe it's down because there's a failure on the node of the in the cloud, or maybe it's down because all the cloud is down. You cannot reach that cloud. So let's move it. But in this case, I'm going to scale it to 0. So I'm simulating a failure. And now we can go back to my example. I can go again to here, Alex, and see that now the request, instead of being processed by GCP, is processed by Amazon. So it's processed automatically without doing anything by the Amazon Kubernetes instance. I haven't done anything in my code. My code is just a simple application, and it's a scupper who detects that Google Cloud is down, okay, and then it needs to send the request to the backend. Of course, what's happening if I recover? So after some time, my cloud is recovered, my GCP cloud is recovered, so my hybrid cloud backend is again up, and I can go here and I can send another message, and now see how the message is again routed to GCP. And the reason that it's always routed to GCP first is because the request is near the GCP cluster. So it just scupper finds which is the cluster near where the request is originated and send it there. Then let me go here. Maybe you are wondering now, okay, but what about the cost? Because you are saying that I can have two clouds, two hybrid clouds, okay? But there is, let's say, one, I would say now, there is one cloud that it's a secondary cloud which never receives any request until the first cloud, the primary cloud, it's failing. And at that case, it will be routed to the secondary cloud. But what's happening with the cost? Because I'm paying for a cloud that I've never used it, or I only use it in, let's say, as a temporal solution. But if I need to have all my pods, all my infrastructure there running, it means that this costs money, right? Because you need to pay for the memory and the CPU that you are using. So what is the solution? The solution is serverless, okay? Serverless, of course, doesn't mean that we do not have servers, okay? Because the servers are still there. Our applications are running, over the rainbow somewhere. And for us in Red Hat, serverless computing, it refers to the concept of running applications that do not require server management. So it means that we just say, hey, I want to deploy my application. I don't care where. I don't care if it's in node 1, in node 2, in node 3, even machine 1, 2, or 3. I don't want to configure reverse proxies, networks, nothing. It just automatically configured. And what is important is that it's executed, scaled, and built in response to the exact demand, which means that if I've got a lot of demand, I've got a spike of traffic, then a lot of instances of, of my serverless application or service are going to scale. Okay, so it's going to create more and more instances. But if I have no requests, then my application, my serverless application is going to be scaled down to 0. And if it's scaled down to 0, means that there is no memory and no CPU used. And if you are into the Kubernetes world, probably you know about Knative. Knative is a project that lets you deploy serverless workloads in Kubernetes. But what is really important about Knative is that you are using base primitives all the time. We are talking about pods, deployments, services, Kubernetes services. Okay, now there's nothing really new. And Knative provides a set of middleware components, okay, to build this application serverless and are container based. And this is super, super critical because suppose that you want to start using the hybrid cloud approach and you want to use serverless and you start using Amazon Lambda. That's fine. But what's happened if someday your client moves to a country where there is no Amazon data center and there is a data sovereignty restriction, so you cannot move your data out of the country, and you discover that it's Azure, there is a data center owned by Azure there in that country, then you will need to start migrating Amazon Lambda to Azure functions, which is fine, but there is a development. But if you are using Knative, since it's container based, the only thing that you need to do is move one container from one Kubernetes installation to another Kubernetes installation. And with Knative, you can scale to 0, which means that there is no pod if there is no traffic, and if there is no traffic, there is no pod, there is no CPU, and there is no memory, means that your cloud provider cannot bill it for it. Also can scale from 0. It means that if there is a traffic spike, then Knative will start creating a lot of pods. You can configure your application and also make revisions. So you can implement deployment strategies like blue-green deployments or canary releases. And also it contains an eventing system. So if you are not into synchronous or request response architectures and you prefer more an event-driven architectures, also Knative can be your choice. So if you want to learn more about Knative, this is the link of the tutorial. I'm going to just show you briefly. I'm going here. What is this? Okay. I'm going to create a namespace. Let's name it, for example, serverless. I'm going to this namespace. Now let me split this here. Let me do a watch of the pod. So now I'm just checking. Oops. Okay, export config. Doesn't matter because now I've got here. You see that in the serverless namespace there is no pods running yet. And what I'm going to do now is deploy a Knative service. Let me move to Knative tutorial. Oops, Knative tutorial, and I'm going to do a kubectl apply -f. I think that this is in apps, no, basics, reader. Sorry, here we can do just a simple service. Okay, now I'm deploying a simple Knative service. In fact, I can show you. Okay, now I can share with you this YAML. Notice that it's a really simple YAML file. It's just time of kind service, and you see that in the API versions of Knative, I just set a container image because remember that I said that Knative works with containers. Then I set here a liveness proof and a readiness proof, And that's all the things that I define. And with just this, I've got my application deployed as a serverless application. And if I do kubectl get pods, you see here the pod. I can do kubectl get deployments. And you see here that there is a deployment as well. It's automatically created. I can do kubectl get services. And you see, wait, sure, if I read it correctly, you see that there is some services also created, but see that my YAML file was these 15 lines, just this. And I can do kubectl, well, I can do the kn service list. Kn is a CLI tool from Knative, and see that also provides me with a URL. So with Knative, everything is configured automatically. I do not need to configure ingress. I don't need to configure DNS, proxies, deployment, services, nothing. I just create this YAML file and everything is done for me automatically. Okay, now you see here that this pod is terminating. Why it's terminating? Because by default, Knative waits for 60 seconds, okay? So if in 60 seconds there is no traffic to send to that pod, the pod is scaled to 0, as I said. By default is 60 seconds, you can configure it to be 30 seconds, 10 seconds, 1 minute, 2 minutes, 5 minutes, whatever, okay? And after that amount of time, if there is no request, then it's scaled to 0, like you can see now. How is the scale up again? Okay, I just need to do a curl of this URL and see what's going to happen. Notice automatically when I send the request, the pod is started and it sends me back the response. And now it will start counting these 60 seconds. So if in 60 seconds I do not send anything at all, then this pod is going to be scaled down to 0 again. Okay. Let me go with the slides. So we can do exactly the same thing that we've done before. You know the example of the sending a request and it gets back with a response. Exactly the same thing, but in this case using Knative. And what is the big advantage of this? The big advantage is that now, if I'm sending all my traffic to GCP and I've got Amazon as a backup, meanwhile, my Amazon cluster is a backup cluster, I can scale to 0. So I can scale to have no pods running, no memory, no CPU, and I start sending all the traffic to GCP. And what's happened when GCP goes down? It will send the request automatically to the Amazon. But remember that there was no pods there because we scale it to 0. But since we are using Knative, automatically the instances will reborn, let's say, process the request and send the response. And this is the demo that I said. You can go here and see that now there is no pod again because it has elapsed this minute. Of course, if I do a curl again, then okay, it just boot up a new pod. Okay. Now let me go to the example that I said before. This is the same as I show you. We can reset. Wait, because I can reset the front end. I'm going to go here. Wait a second. Okay, now I'm resetting the application. And what I want you to see is that now, instead of using Amazon as a backup plan, we're going to use Amazon, okay, as to cover a spike of requests to one data center. So I've got one data center in GCP and another, the same application, okay, in Amazon. And with the scupper, as I said before, we can use a cloud as a backup cloud, but we can also use it as a way to receive traffic when there is a spike. So for example, suppose that I'm in GCP, I'm getting a lot of users to GCP, I'm receiving a lot of requests, and arriving at one point, I know that GCP cannot afford more requests. So what it does, Scupper, is start sending this request to another cloud, in this case, Amazon. Now I'm going to do Alex, and I should, for example, uppercase, I send the request, and by default, it goes to, you see, wait a second, no, I'm going to change here. It will crawl front end. No, let me go to the backend, which is here. You see that it's scaled to 1, and here it says Aloha Alex GCE, okay, Google Cloud. I can do Soto if you want. Okay, send the request, and then it go to Soto, it goes to the GCE. And if you see here, this is the cloud that is running. You see that in this case, I think that I configured that in 10 seconds or 30 seconds, it scaled down. Let's wait for this 50 seconds. Let me check if it's still, yeah, 16 seconds. See here, you configure knative with annotations and with autoscaling.knative.dev/window. You're setting this to 16 seconds. It means that after 16 seconds of not receiving any traffic, the pod will scale down. Okay, now notice how after the 16th second, the pod is scaling down to 0. Okay, now let's start sending a lot of traffic to my application, to this application. What's going to happen is that traffic is going to go first to the GCP cluster. You'll see how this pod is scaled to 1, and at reached one point, it will start sending traffic to that other cluster, which is on Amazon. See that now both of the clouds, both of the deployments are 0. It means that there is no service running. And I'm going here, and I'm going to do Hey. Okay, Hey is a tool that allows me to, in this case, sending 35 concurrent users sending requests without non-stop during 2 seconds. Okay, then I run it, and let's go here. This is GCP. See how it's scaled up automatically? Okay, and see how the Amazon also is scaling at the same time. Well, it's not in the same time. It's, you know, when I reach the level of the GCP, then it switches to start sending requests to the Amazon. See how both of the clouds are up and running now. All the, you know, I get it, all the responses, and in a few seconds, I mean that in 16 seconds, you see how the pods are start scaling to 0. In this case, it starts with the Amazon, and then it will start continue, you know, now with GCP. Oops, no, I don't know. I am here. Let me go down here. Oh, because it's okay here. Again, here you can see all the URLs for running these examples on a Kubernetes. And when I say Kubernetes, I mean vanilla Kubernetes. You can just use the same demos with Minikube. You're going to start 2 Minikubes on your machine and run them as an hybrid cloud, and you can, you know, stop 1 Minikube or scale down and so on. You can also use, for example, if you have a Google Cloud or GKA, you can run it there. So it works. Scupper works with vanilla Kubernetes. Although I demoed it with OpenShift, that's true, but you can use any of the Kubernetes installation, because a Scupper it's just an open source Kubernetes project. So let's went down. First of all, as I said, Kubernetes or OpenShift, it's the best tooling out there for hybrid cloud because it helps you having a standard experience. Okay, you've got a common experience across all the clouds. Scupper, this is the project that I've showed you now, which is this one, which is multi-cloud communication, as you see, for Kubernetes. So it doesn't matter if it's an OpenShift, if it's a GKA, a AKS, or whatever, it doesn't matter. It works. And as I said before, it works at layer 7. Okay, which means that works with no, it doesn't matter if there is, I mean, it doesn't require VPNs or special firewall rules because it's just HTTP. here. Also, take a look at the JClouds project, which helps you also in the hybrid cloud and Java. The examples that I showed you today, in github.com/Red Hat developers demos/hybrid cloud. This is the first demo where we show you how you can use hybrid cloud for backup plan. Then there is this Red Hat developers demos/hybrid cloud serverless. That is the demo that I run it a few seconds ago. And that I show you that with sense of serverless, you can start adopting hybrid cloud and not get it crazy about the cost. And the last demo that I've not shown you is that this is in the Red Hat developers demos/hybridized to-do app, which is a really cool application, which is a to-do application where there is a database. So what's happened when there is a database in my hybrid cloud system, right? Because I've seen you've seen there stateless application, but what's happened when my application is stateful, when there is a database, how I can also make my database be into the hybrid cloud system. So I can deploy some nodes of my database in some clouds and another nodes in the other clouds. And when the database is down in one cloud, I'm not losing any data. And check it because it's a really cool demo. Under the coverage is using Cockroach DB. And now, yes, that's all. Remember that if you've got any question after the session, you can ping me in Twitter, which is Alex Soto B, and also my email, sotob@redhat.com.